Hello, that's our first lesson from the physics, and the topic that we are going to learn is the researching method in physics. So let's first start by remembering what's the physics actually. Physics is the natural science of matter involving the study of matter, its fundamental constituents, its motion and behaviors through space and time, and the related entities of energy and force. Physics is one of the most fundamental scientific disciplines, with its main goal being to understand how the universe behaves. Physics is one of the oldest academic disciplines, and through its inclusion of astronomy, perhaps the oldest, or much of the past 2 millennia, physics, chemistry, biology, and certain branches of mathematics were a part of natural philosophy. Advances in physics often enable advances in new technologies. For example, advances in the understanding of electromagnetism, solid-state physics, and nuclear physics led directly to the development of new products that have dramatically transformed modern-day society, such as television, computers, domestic appliances, and nuclear weapons. Well, physics is a natural science that requires observations, which in turn forms hypothesis or experiment, while both of which hypothesis and experiment form physical laws, and lastly physical laws form scientific theories. So okay, let's now talk about each of them one by one. So now let's start with a hypothesis. It's a proposed explanation for a phenomenon. For a hypothesis to be a scientific hypothesis, the scientific method requires not that one can test it. Science is generally based scientific hypothesis on a previous observation that cannot satisfactorily be explained with the available scientific theories, even though the word hypothesis and theory are often used interchangeably. A scientific hypothesis is not the same as a scientific theory. A working hypothesis is a provisionally accepted hypothesis proposed for further research in a process beginning with an educational guess or thought. Next one is an experiment. It's a procedure carried out to support or refute a hypothesis, or determine the efficiency or likelihood of something previously untried. Experiments provide insight into cause and effect by demonstrating what outcome occurs when a particular factor is manipulated. Experiments vary greatly in goal and scale, but always rely on repeatable procedure or logical analysis of the results. There also exist natural experimental studies. Now let's talk about a physical law or scientific law. It is a scientific generalization based on empirical observations of physical behavior. Empirical laws are typically conclusions based on repeated scientific experiments over many years, and which have become accepted universally within the scientific community. The production of a summary description of nature in the form of such laws is a fundamental aim of the science. And lastly, the conformity principle. It states that under individual conditions, the new theory must be consistent with the. So that's the end of our first topic. I hope that you gained a lot of useful information. Thank you for watching the video. Goodbye. See you soon.